In this video, let's try to understand how can we actually implement the get operation on a singly linked list. So the main purpose of get functionality on a singly linked list is to retrieve the node that is available at a specific index. So as part of this get functionality implementation, what exactly we request from the user is basically the index. Index is nothing but the position at which the node is requested by the user. So first, let's try to understand how the indexes actually work in the case of singly linked list. So it is not a complicated thing. If you happen to know arrays concept, right? We know in the arrays the index starts from 0 and ends at the length of the array minus 1. Similarly, in the case of singly linked list also, the index will start from 0 and ends at length of the linked list minus 1. So if I have to add the indexes to the nodes that we have inside the singly linked list, right? Let's try to do it on a sample linked list that we can see here. So here we have a singly linked list containing 6 values in it. So obviously the starting index will be 0 and the ending index will be length of the linked list minus 1, that is 5. So here the very first node, that is 10, will be available at index 0. Similarly, the node with the value code will be available at index 1. Similarly, the node with the value true we have at index 2. Similarly, all other nodes also we can give the index value. So as part of the get operation, if the user passes a certain index, right, we have to return the node that is available at that particular index. So we are expecting the index value also from the user from 0 till the length of the linked list minus 1 as part of the argument. So that is how we actually represent the indexes in the case of singly linked list as well. Now let's go ahead and let's try to understand what all are the different cases that could possibly come when we try to implement the get functionality. So let's just try to understand the different cases. Obviously here we are taking the index as an argument from the user, right? So user might not be aware of the length of the linked list and can give the index that is beyond the maximum possible index or any negative value as well. So we have to handle those cases as well. So as part of the first case, let's try to handle invalid indexes. So the minimum possible index is 0 and the maximum possible index will be length of the linked list minus 1. So any negative values or any values beyond length of the linked list minus 1 are actually invalid indexes because the nodes that are available are at index 0 till the length of the linked list minus 1 only. So if any other value comes, first what we have to do is we have to simply return null or none based on our choice of programming language. If you are using Java or JavaScript, you will simply return null. If you are using Python based programming language, you will simply return none in that case. Because user has passed some invalid index, that could be negative index or it could be the index that is not in the range of whatever the indexes that we have in the singly linked list. That is the case where we handle the invalid indexes. If the second case is actually the valid indexes given by the user. So if the user has actually given the valid index, right? So our job is to start at the head node and we have to go to the node that is given by the user at that particular index and we have to return the entire node here. Okay, we are not simply returning the value we have in the node, rather we are returning the complete node. Okay, why? Because we can reuse this get functionality in the future operations such as set, insert, delete, and all these functionalities we can reuse this get functionality. That's why we make sure that we are returning the entire node object but not the value. Okay, so how will we actually do that, right? So we will, let's assume that the index that user has given is, let's say, 3. So that means that my program should return the node that is available at index 3. That means I should return the node test as a output. So what exactly I will do is I will start traversing the linked list at the head node, because in the single linked list that I'm implementing, I have the access to the head node, I have the access to the tail node, I have access to the length of the linked list. Now Since I have the head node, I can start traversing at head node. From head, I can go to the next node, right? Because each and every node has the reference of the next node. That means if I go to the next node, I will be at index 1, which is not the index that user has requested. So on index 1, I will again read the next node. I will go on to the index true, right? Now this is at index 2. That is not the index that user has requested. User has requested the node at index 3. So again, from the next that we have on the node true, I will go on to the node with the value test. Now my index is 3. So I can simply return the node with the value test as a output here. Okay, so for going to the index that is available at a given index, we will simply be running a loop. How will I exactly run the loop? That I will show you when I write the pseudocode as well as the programmatic implementation. But this is how, this is the overview of how we can implement the get functionality based on the index that user is passing. Okay, now that we have understood the different scenarios that could arise while implementing the get functionality, right? Let's try to write the pseudo code for implementing the get functionality as well. So here what we will do, we will simply write a function called get, and here we will be taking the index from the user. So when we discuss the algorithm, right, what exactly we discussed, there will be two checks. The first check is to check if index is invalid. So how will we check if the index is invalid? Internally in the singly linked list representation, we are keeping track of the length of the linked list. That means we know the minimum range is 0 and the maximum range is length minus 1. If at all, if the user is, whatever the index that user is passing, if it is less than 0 or greater than or equal to the length, that means that is a invalid index. Based on that invalid index, if the user is giving, right, obviously we will not have the node at that particular index, so we will simply return null or none based on our programmatic implementation. If we are using Python, we will simply return null, none. If we use JavaScript or Java based representation, we will simply return null here. Okay, so this is the case if the index is invalid. Okay, as part of the next scenario, we have to handle the valid indexes. So anything that is not falling onto above range, that is if the index is falling in the range of 0 till the length of the linked list minus 1, that user has given a valid index. Now here what we have to do is, I will simply define a variable called current node, and I have the access to the head node, right? I will simply assign head node to it. Similarly, I will define one variable like counter and I will initialize it with 0, because right now the node that I'm processing is at the very first node, right? Let's assume that I have a singly linked list containing, let's say, 4 values. Let's say 10 code, let's say true and false. The index that user has given is 3. Let's assume 0, 1, 2, 3. This is the head node, this is the tail node. Since I am starting at the head node, right, the counter I am initializing it with 0. Now what I will do is, I will simply run a loop while this counter is not equal to the index that user has given. That means that I am not at the index that user has passed. Inside this while loop, what we can do, we can simply, we have the node reference. On the node we have the next available, right? So we will simply update current node variable with current node dot next. In that way we are simply moving on to the next nodes, and since we are moving on to the next node, the counter should be incremented by 1. So counter should be counter plus 1. Once we go to the index that is given by the user, right, the current node will be available at that index, and the current node variable whatever we are using will be having the reference of the node that is available at that particular index. So we will simply break out of this loop. In the end we will simply return the current node. Okay, this is how we exactly write the pseudocode for implementing the get functionality on a singly linked list. So for that, inside the singly linked list class, let me just add a function called public node. Basically, we need to return the node at the index that user has given. Node, let's name the function as get, and it will basically take the index or the position at which the user is requesting the node to be returned. So for that, so whatever the position or the index that user is passing, right, it could be valid or it could be invalid. So first let's check for the invalid cases. So first, as part of the first check, what I will do is I'll basically check if the index value is less than 0. That means that if you remember that, whatever the operation that we are trying to perform, we are making sure that if the list becomes empty, we are making sure that we are maintaining the length of 0. That means that at any point we are not maintaining negative values in the index. So if index is less than 0, that means that there are no, whatever the index that user has passed is invalid. If this is the case, or whatever the index that user has passed is more than or equal to length, we already know that we are going to consider these indexes just like the case of, we consider the indexes in the case of arrays, right? In the case of arrays, we have the index starting from 0 ending at length of the array minus 1. Similarly, in the case of the singly linked list also, we will be considering the indexes from 0 to length of the singly linked list minus 1. So what we can do here basically to check if index is greater than or equal to this dot length, which will basically, whatever the value that user has passed, we are comparing it if it is equal to, greater than or equal to length. That means even if it is matching the length, that is not possible. The possible range is 0 till length of the singly linked list minus 1. If user passes any of the index values in such cases, we can't get the value, we will simply return null. Okay, besides this, if this is not the scenario, what we need to do, we need to iterate over the entire singly linked list, and we need to go to that specific index and we need to return the node we have at that particular index, right? For that, what I will do is I'll simply initialize couple of variables while I equal to 0, and I will also define one variable called node, the current node, and I will assign it with the head node. Okay, now we need to run a loop while, as long as this I is not becoming the index. So I is not equal to index. What we will do, we will simply go on to the next node. That is, we will simply update the current node to current node dot next. Okay, once it is done, we will simply increment the I to I plus 1. Okay, once this while loop is completed, right, once this I matches with the index value that user has passed, we will break out of this loop, and whatever the value we have in the current node will be the node at that particular index. So we will simply return the node which is available in current node. Okay, very simple operation. If the user passes an index value that is less than 0 or more than or equal to length of the singly linked list, we can't find the node because the possible ranges for the index are from 0 till length of the singly linked list minus 1. For any other scenario, we will simply define two variables. We will run a loop as long as this I is not matching with the index. We will simply go on to the next node from the head node. Once we reach that index, this loop will break, and whatever the value we have in the current node will be the node at that particular index, because we are simply updating, inside the loop we are moving on to the next node till we match that index. So we are simply returning that specific node. Okay, now let's try to call this and let's see if we are able to get that node. So here, let me just comment out this shift operation. Okay, let me just uncomment these push operations so that we will have some values in the singly linked list. Now if I simply call sll dot get, I want to pass the index, right? Let's say I want to read the value at index 0. That is the very first node itself. That is the node with the value 10. Let me just capture it node, result node. Let me just print it. Sys out of result dot value. Okay, let me just comment out this traverse function because we don't need it anyway in this. And if we are not doing anything to head and tail node, right, so they will still be same anyway. I don't need this print also, but if you want you can print it out and validate that too. If I execute this now, if you see, the value at index 0 is nothing but the very first node in the singly linked list, so that is 10. Okay, I'm reading and I'm returning that value. Similarly, if I want to read the value at index 3, that is the last value or the fourth value in the linked list. Let's say if I want to read the value at index 3, so if I execute it, run as Java application, I've got the 10.0. okay, similarly if I pass more than or equal to length of the singly linked list, I should basically get null, right? So that means null dot value printing is not possible. So let's just print the result. Java application null is what we have got. Even if we pass any less negative value also, we should see the same result. Okay, this is how we basically perform the get operation on a singly linked list. Now that we have implemented the get functionality on a singly linked list, let's just try to understand the time complexity and space complexity involved in the implementation process. And both these also let's just try to understand in terms of best case scenario as well as in the worst case scenario. So when will the best case scenario of get operation will actually occur? Whenever the index that user is passing, if it is equal to 0. That means that let's assume that our singly linked list contains some number of nodes, right? And we have the head node and we have the tail node. When the user passes an index 0, whatever the iteration logic that we are executing for reaching the node at that particular index, right, that will not even get executed. We will simply return the current node immediately. So obviously, since we are not running the loop, the time complexity will be order of 1 in the best case scenario that occurs when the index that is given by the user is 0. Now, when will the worst case scenario will actually appear, right? Let's assume that the singly linked list on which we are trying to perform the get operation has n number of nodes. So the worst case scenario will actually appear when we are trying to read the or get the value that is available at the very last index. That is, the index that user passed is equal to length of the linked list minus 1. In that case, we will have to start traversing at the head node, and one by one node using the next references we have to reach the very last node. That's why whatever the iteration logic that we are writing, right, it will get executed for n number of times. As a result, the worst case time complexity will be order of n in worst case scenario where the index given by the user is n minus 1, and in the best case scenario the index that is given by the user is 0 and the loop will not get executed and the time complexity will be order of 1. Now that is in terms of time complexity. Now let's just try to understand in terms of space complexity. Be it best case or worst case, what exactly we are doing inside, even if we execute the iteration logic that we are writing for getting the node, right, there we have basically defined two variables. One is to keep track of current node that we are processing, and the other is a variable called counter, which keeps count of how many number of times we are iterated. Basically it keeps track of, if the index is matching with the index that user has passed, right? And we know these two variables will take constant amount of memory. So obviously, even if it is the best case or worst case, same variables will be reused. As a result, be it best case scenario or be it worst case scenario, the space complexity will be order of 1 only. Why? Because we are simply using the same current node and counter variables for keeping track of the next node that we are processing and the index that we are currently processing. Okay, so that is the way we calculate the time complexity and space complexity for get operation on a singly linked list. Okay, in the next video we will see how can we reuse this get functionality for implementing the set functionality on a singly linked list. Okay, I'll see you there.